Hey everybody, welcome to training video number 1 of the Masterclass for PyTorch 2.0. I'm Joe Papa, author of the O'Reilly PyTorch Pocket Reference, and I'll be your instructor for the course as we go through this. I'm super excited about PyTorch 2.0. I've been working with PyTorch since, some of the early days when PyTorch was released. I was running an AI team over at Peloton Labs, and we started using PyTorch, and I was super excited about it. We've used PyTorch to develop some really cool technology, and I went on to write a book about it. And now, for the first time, there's a major release in PyTorch, and I'm super excited about this 2.0. So here's what I want to tell you about 2.0 in this video. You can go to the PyTorch website, and there's a nice blog post on there. I'll show you the URL for that here, and that'll give you information on 2.0. But what I want to do is, in these training videos, show you exactly what you need to know. And I want to explain some things that are not in that blog post, okay? All right, so let's talk about what we're going to cover in today's training video. In training number 1 of the PyTorch 2.0 Masterclass, the first thing we're going to talk about is why should you even learn PyTorch 2.0? Why is it so important? And I believe that this is much bigger than everybody is even talking about it. This is such a huge leap for PyTorch. I'm super excited to go through this training today. The next thing we're going to talk about is what's the major change in PyTorch 2.0. What do you need to know about this change? And the last thing we're going to talk about in this video today is how to start using PyTorch 2.0 right now, and I'm going to show you how to do it in just a few minutes. Okay, so let's jump into it. Why learn PyTorch 2.0? Why is it so important? The first thing you want to understand is why 2.0, right? So PyTorch was at release 1.13, and they could have very well came out with 1.14. Why jump to a major release number? And the other question is not only why did they jump to 2.0, but what does this mean for you, right? So why is 2.0 such a big deal? So let's talk about that. 2.0, I believe, is such a big deal. I don't think it's really being the true story is being told here, and I want to emphasize that in the video. So let's just talk about that. So the first thing you need to understand if you want to understand 2.0 is what made PyTorch so popular to begin with. And what made PyTorch so popular over the past 3 or 4 years to kind of, when it first started, TensorFlow was really the leader. And when PyTorch came out, this component of PyTorch really made it what it is today. And that concept is the dynamic computation graphs. That's the feature of PyTorch that made it so popular. Now, what does that mean? That means that it really essentially means So why do you need to know dynamic computational graphs, and what does it mean? Well, think about it. PyTorch is used to create neural networks, right? It's used to design them, train them, test them, deploy them. Neural networks, which are the foundation for deep learning, which is the foundation for artificial intelligence when you break it down. And the important thing here is that when you're developing neural networks, you want to make it easy for researchers and developers to go ahead and create these complex neural networks and be able to train and test them and deploy them. So the concept of dynamic computational graphs is the concept that you can create a neural network in a very easy way with the easy API. Now, if you think of a neural network, it really comes down to 3 things. It comes down to the architecture, right, with all the parameters associated with that architecture. But there's also logic and control. So for more complex neural networks, you might have some really interesting creative things going on under the hood as opposed to just like a static graph, right? It may not be a static graph. There may be some dynamic components to it. And the key feature of PyTorch and what made it so powerful was that it gave you the ability to build dynamic computational graphs and train them without having to compile them or optimize them in the beginning. And this just totally exploded the use of PyTorch. Now, the benefit of doing it this way is that it's flexible and easy to use, right? So you can create many different types of neural networks and be able to implement them and debug them fairly easily. It uses a concept called eager mode. Now, if you're familiar with TensorFlow, you'll know the difference between eager execution and graph execution. PyTorch calls them eager mode and compile mode, right? And the essential difference is this. Eager mode is, hey, I just want to try out my neural network. I want to build it very, very quickly. I want to try it out. I want to see what kind of results we get with that neural network. The code is executed in sequence. So if you build a neural network, you can, kind of step through the code and you'll see that, the first layer of the network is passed in some values in the forward pass, the next layer, and so forth. Very simple, very intuitive. With graph execution or compile mode, it works very, very differently. And the difference is that in that case, you're going to take this neural network and you're going to sort of reshape it and redesign it so that it performs in an optimized fashion. Okay. If you consider just a standard neural network, it may not be, sending in data in sequence may not be the most efficient way to do it, and oftentimes it's not. So that's why they have compile mode or execution mode. So the reason why you need to understand this for 2.0 is 2.0 solves a problem, a key problem for PyTorch. And that's that the problem with dynamic computational graphs, the way that PyTorch does this, is that they're not optimized, right? We're not optimizing them. There are some features of PyTorch like TorchScript and other features where we're optimizing things maybe on the inference side, but especially on the training side, there were not many good options to optimize your graphs. And this is a big shortcoming. So when you think about it, it's kind of interesting because the most powerful part of PyTorch, namely dynamic computational graphs, was actually what was holding it back. And that's when TensorFlow seemed to have an advantage over PyTorch in the recent years, was that when you go to deploy these things, or when you're going to train like large language models or very large neural networks with immense amounts of data, and the complexity of the state of the art is growing exponentially, now this is holding PyTorch back. So what happens in 2.0 is 2.0 introduces a feature that solves this problem. What's the major change in PyTorch 2.0? Okay, and it's very, very simple. So what's the major change in PyTorch 2.0? It's actually so simple and so complex all at the same time. The biggest feature change is that with just one line of code, you can take your neural network model and optimize it. Right? I'll say that again. One line of code, you take your neural net model and you optimize it for training or inference. And it increases the performance 1.5 times, 2 times, and higher of a lot of large language models and very complex models, as well as simple models as well. Now, what does this mean? Well, if it took you a week, or it took you 2 weeks, or let's say it took you, 6 days to train your neural network, you could reduce that to 3 days of time. Think of the amount of compute cost that saves, development time that saves. It's a tremendous, tremendous improvement. And the neat thing about this is that you're only adding one line of code. It's backwards compatible. And we'll talk about some of the details once you get into development in the next training video. But what I want to show you here is just that the key feature to 2.0 is this compile mode. And you can take your model as it exists, or any model, and add one line of code, and now you have an optimized version of that model. Now, I also said it's very complex as well. So the implementation of it is very simple, but what's happening under the hood in PyTorch is actually very complicated. And the PyTorch team has spent many years trying to figure out how to do this. And if you could think about it with dynamic computational graphs, that things can get pretty complex. And to be able to cover all of these different scenarios and complexities and be able to optimize a neural network, that's a very challenging problem. So I want you to appreciate that under the hood, there's a lot that goes on. But if you just want to try this out and implement it and see what kind of performance you get, it's just one line of code. And we're going to show you how to do that in just a moment. One thing I want to point out is that even though it's one line of code, there are a number of parameters that you can pass in to the compile function. And this shows you a demonstration of what the compile function parameters exist. There are 4 of them: mode, dynamic, full graph, and backend. And I want to tell you just very quickly what you need to know about this. And this is what people are really not talking about on the internet or even on the PyTorch site so much. Let me briefly explain what these are and why you should care about them. Number one, I could say that the last 3 just keep to their defaults. Okay, let's just talk about the last 3 first. The first one, dynamic, that's just a Boolean. You can set that to true if you have dynamic components of your neural networks. In other words, if you're using logic and flow and control flow in your neural networks, you probably want to set this to true. But I can tell you that at the time of this recording, we're recording this in January 2023. At the time, PyTorch 2.0 isn't even in a stable release yet. All right? And they're working through a lot of the details when it comes to dynamic components of graphs, of the dynamic computational graphs. So if you do have dynamic graphs, that might be something maybe you want to explore or hold off on. Try to stick with something that is a little bit simpler. The full graph parameter is something that you definitely want to keep to false, especially when you're starting out. Full graph tends, if you set it to true, it looks to do further optimizations using some complicated processes or complicated techniques. The problem with setting full graph equal to true is this requires you to do some manual changes to your neural networks. So you definitely want to keep this at the default false. And the final one, which is backend, is using a backend to do all these optimizations. PyTorch has a built-in component called the inductor, which we'll talk about briefly in the next training session, but I don't want to get too caught up in the details of what they're doing in the backend. The thing you need to know here is that there are other backends. There are other things that people have developed, so you can use this parameter to try out other backends. For the time being right now, when you're going to start off, is you can use the default settings for all of these. You definitely want to use default for the final 3, the last 3, dynamic, full graph, and backend. The only one that you might want to play around with is mode. And there are 3 modes. The first one is default, and that just gives you like, hey, here's our best shot at compiling this, given some reasonable compile time, right? We don't want to spend days crunching our neural networks to optimize it. We want to do something in reasonable time, and default will do that for you. There's 2 other settings for this that you can use. One is called reduce overhead, and reduce overhead will, like it sounds, attempt to reduce the overhead of your neural network at the cost of increased memory. So if you have a neural network and you're looking to reduce the overhead and you have plenty of memory available, you might consider using this mode, reduce overhead. The other mode you might consider is called max auto-tune. Now what max auto-tune does is it's going to take a little bit longer to compile, but you may get better results. So that might be something you want to play around with if you try out the default setting for mode and it's like, pretty quick to compile your neural network. Maybe you give max auto-tune a try and see if it takes a little bit longer. That's not such a big deal to compile your neural network, and you might get increased performance based on that. So those are the parameters for the compile function, which is just one line of code. You always pass in the model, and if you don't pass any of the parameters, we'll just use the default ones, but you might want to change the mode, keep the other ones the same, and I think you'll be in good shape to begin with. how to start using PyTorch 2.0. Okay, so hopefully you're super excited about PyTorch 2.0 and you want to start using it like right away and try it out on some of your existing code, or maybe just go through an example tutorial and try it out. Well, I'm going to show you how to do that really simply. I know that everybody uses different development environments and maybe use Mac or Windows or Linux. I'm going to show you how to do it on using Google Colab. And it's very similar for other programming environments, but this is the simplest way to show it for everybody. If you're not familiar with Google Collaboratory, just Google it, sign up for a free Google account. You can get the free version. All of this should work on that if you want to try it out. Google Colab comes pre-installed with PyTorch. The thing is though, 2.0 is like a new release. It's not even a stable release. They're doing it in the nightly releases right now, so it's still experimental. So when you look at Collaboratory in the time of this recording, which we're doing this in January 2023, PyTorch, let's check the version of PyTorch. So no matter what environment you're using, or maybe you're doing this later in the year when PyTorch 2.0 is now stable, here's how you would check to see what version of PyTorch you're using. Let me increase this so you can see it here. But if we open a notebook, just do import torch to get PyTorch, and then what we're going to do is just print the torch dot version. We put 2 underscores before and after, shift enter that, and now we can display what version of PyTorch we have installed here. Okay, so we can see here that I'm using 1.13, right, which is the latest version prior to PyTorch 2.0. We can also see that we're using CUDA 11.6, and that's important. So whether you have CUDA installed or not, and which version of CUDA is important as well. Now, if we want to upgrade to PyTorch 2.0, it's very easy to do. We can use pip to install this. And if we go to the main blog here, you can find this command here. Let's scroll down. But basically, it will show you how to install this. So if we go over to, I think, getting started, and there's some FAQs, and we show here is how you would install the latest nightly versions for depending on whether you're using CUDA or not. Since we're using CUDA 11.6, we can just copy this line here. So let's copy this, go back to our Colab, and we can paste that line in here. All right, so let's take a look at the line. We're going to use pip. We want to put an exclamation point in the front here, and that's going to tell it to run. It's going to tell Colab to run this notebook using this command. If you're using another environment, let's say you're using VS Code and you have Python and PyTorch installed on your local machine, you would just go to your terminal and set your Python environment correctly, and then use pip to install this. And I would recommend setting up a new virtual environment in your Python environment. If you don't know how to do that, you could just Google that, but most people use Conda or Anaconda. There's a number of different ways to do it. Set up a new environment, that way you don't screw up your old environment, and you can go ahead and just run this pip command, and it will install everything for you. So here are some flags you need to set. This -- pre for Torch Vision and Torch Audio as well. If you're not using those, you probably don't need them, but if you want to be safe, just use this line as it stands. So we'll shift enter that, and we can see that we're downloading a bunch of things, and we're going through this. So this is going to take a few minutes to complete, but what we're doing here is we're installing PyTorch 2.0 and the necessary dependencies into this Colab environment. All right, and we'll see that once this is finished, we'll need to restart our runtime environment. And again, this will be different if you're using a local installed version or not. But the idea is the same. The first thing you want to do is check the version that you currently have installed. If it's not 2.0, then you want to go ahead and use this pip command to install PyTorch 2.0. So let's give this a few minutes to run and we'll come back. Okay, so after about 5 minutes or so, that should complete and you'll get this button here, restart runtime. So let's go ahead, click that, say yes, and that's gonna restart our runtime for us. And you'll see here, it'll start initializing and we're ready. So now let's import Torch again. All right, let me scroll this up. We're gonna import Torch again, and then I also want to import some models from Torch Vision just to show you really quick how easy it is to start using the compile feature of PyTorch 2.0. So we'll do from Torch Vision, import models, and that will give us access to all the models in Torch Vision. Let's build one, so we'll say model equals Torch, models, and we could use ResNet, so we'll just use like a ResNet 18 for example, and create a model that way. You can use whatever model you want or something that you already have, that's fine. I'm just using this to demonstrate how it would work. Now to do this, let's just print out this model and see what it says. So it does give you information when you print out models, the model objects. We can see here that it's a ResNet model. You want to look at the architecture. We can see, it's made of convolutional neural networks, bunch of different layers, etc. So you can look at all the makeup of ResNet 18 here. If we go to now to create a compiled version of this, very easy. Here's how we do it. We'll call this optimized model, and we're just going to use torch.compile, and we'll pass in the model. Okay, again, you can see the different options are popping up here, but we're just going to use the default, and that's it. So we just pass in the model, shift enter, and it will say the runtime's not found. This is fine, it's just using this, and we see that here we have a compiled model. Look how quick that was, super easy. If we go ahead and print out that one, we'll see now this is an optimized module. That's the new object here. Okay, so it's a little bit different. It's optimized, it's changed the module to something different, and now it's more efficient. That's how easy it is. This one line of code is all you need to use the compile model. In the next training video, we're going to talk more about PyTorch development using 2.0. And we're going to talk about some of the downsides of 2.0. In this video, this is where we're going to show you what you should do with your existing code, or if you want to create new code, should you start using 2.0 or should you use 1.13? We're going to cover various different topics related to that. We're also going to talk about what happens if you use 2.0 and then your code crashes. How do you handle that? As well as what if the performance decreases, right? Say you want to use 2.0, you go use the compiler, all of a sudden your performance decreases. What do you do about that? We'll talk about that in the next training, but before we go, I want to challenge you with the PyTorch challenge. Now, this is very important, so stay with me. We just tackled some very important concepts about PyTorch 2.0, and I want to challenge you to demonstrate that you've learned those concepts by posting on LinkedIn. And this is critical to the learning process. Whenever you learn something, to totally integrate it into your brain, into your mind, into your body, you should act on it. The best way to do that is to explain it publicly on LinkedIn. And it's going to be so easy to do. All you need to do is go on LinkedIn, create a post, and I want you to answer those 3 questions, right? This is your post outline. First thing, hey, I just took some PyTorch 2.0 training. Here's what I learned. Here's why you should learn PyTorch 2.0. Why is it? Why is it so important? The second bullet would be, what's the major change? Here you go, folks. The major change in 2.0 is the compiler, and it's just a one-line change. If you're looking at parameters, really the only parameter you need to know is mode. Third, here's how you start using PyTorch 2.0. Now, this is where it's personal to you. So in your development environment, do a screenshot. If you're bold enough, do a video. Show people how you set up your environment to use PyTorch 2.0. I know you're up for it. If you really want to show that you mastered this, go ahead. It's a lot of fun. Post this to LinkedIn. Tag me in it so that I know that you've done it, and help people learn this. Share your knowledge. Show that you're the expert in PyTorch by posting on LinkedIn. And if you're not on LinkedIn, go and join LinkedIn. This is an ad for LinkedIn. I don't care about LinkedIn. This isn't about social media either. I'm not trying to get more likes or whatnot. This is really about you learning and demonstrating and integrating what you've learned in this video. It's a critical point to nailing this down as in part of your brain. So I want you to go ahead and do that. Will you do that for me? Will you go and commit to this? I hope so. Go out there, tag me, let me know what you're doing. If you don't have LinkedIn, send it in an email to somebody and CC me on it. Whatever it is, just go there and do something with this new knowledge. Look for your email inbox, and in a couple days I'm going to show you the link, send you a link for training video number 2. Can't wait to see you then. Thanks for watching the video. This is Joe Papa. I will see you soon.